Inside almost every single cell in your body, there are these tiny, powerful engines called mitochondria. And honestly, how well they run might just be the single most important factor for how you age, how you feel, and how you fight off disease. And trust me, there's a lot more to their story than you probably think.
Right. We all remember this one from high school biology class, don't we? It's like the one fact everyone knows about mitochondria. And yeah, it's true, of course, they generate our energy. But that simple definition, it's kind of like calling the sun a light bulb. I mean, it completely misses their absolutely crucial role in how we age, in chronic inflammation, and in the development of pretty much every major chronic disease out there. So, what's the real story?
Okay, so let's properly introduce these microscopic heroes because they have a story that is way more complex and, frankly, way more fascinating than just being simple power generators. First off, their origin story is just incredible. Get this. Mitochondria were once separate, free-living bacteria that over 1 billion years ago formed this wild partnership with our ancient cells. Because of that, they actually carry their own unique DNA, totally separate from the DNA in our cell's nucleus. And here's a fantastic piece of trivia for you. All of your mitochondria, every last one, were inherited exclusively from your mother. So how do these little heroes actually power our lives? Well, you can think of them as a super sophisticated on-demand power grid for your entire body. The energy they produce comes in the form of a molecule called ATP. This stuff is literally the universal energy currency for all life. Every single muscle contraction, every nerve impulse, every thought you have is paid for with ATP. It is absolutely essential. So, how do they make it? Picture a biological assembly line. Fuel, in the form of glucose and fats, arrives at the mitochondria. They then pull these high-energy electrons from that fuel, use them to create a powerful electrical gradient, and then they harness that gradient to just churn out massive amounts of ATP. It's an incredibly efficient process, but it has one critical and ultimately very dangerous weakness. And here it is. Here's the central problem. Unlike the rest of your body, which can store energy as fat or as these long chains of sugar called glycogen, mitochondria have no storage tank. Zero. They can only make ATP exactly when it's needed. And this on-demand system works perfectly until it gets overwhelmed. And that right there brings us to the core conflict of this whole story, the constant, overwhelming flood of fuel that basically defines modern life. To really understand this, let's use an analogy. Imagine your mitochondria are a solar power station. When the sun is shining, they generate electricity. Simple enough? But what happens when it's an incredibly sunny day, way too much fuel, and all your storage batteries are already completely full? Well, the station has no off switch. The excess electricity just has nowhere to go. The whole system overloads. This is exactly what happens in our cells when we're constantly consuming too much fuel, especially glucose, and our body's storage systems are already full to the brim. So, what are the consequences of that overload? In our solar power station, the wires would heat up, fuses would blow, and you might even get some small electrical fires. Well, inside your mitochondria, something very similar happens. The production line gets all backed up, and those high-energy electrons start to leak out. They react with oxygen and form these highly damaging molecules called free radicals. You might have heard of them as ROS. These are the sparks that literally start fires inside your cells. Now, our bodies do have a brilliant safety system for this, and it's a hormone called insulin. When fuel levels get too high, insulin acts like a safety valve, diverting all that excess glucose away from the mitochondria and pushing it into storage in our muscles, our liver, and our fat cells. The thing is, this system evolved for a world of feast and famine, right? Not for a world of 3 carb-heavy meals plus snacks every single day. So what happens when that safety valve is forced open for way too long? When the storage tanks are constantly full, the system finally breaks, and that is when a really devastating cascade of damage begins. The very first stage is a massive increase in those free radicals we talked about, leading to something called oxidative stress. This is where those cellular sparks start to damage everything they touch, the delicate membranes of the mitochondria themselves, and even our DNA. So the body sees all this damage as an attack, and it does what it's supposed to do. It activates the immune system. But because the overload is chronic, it's happening all the time, the immune response never shuts off. And this creates a low-grade, persistent state of inflammation throughout the entire body. an invisible fire that silently just chips away at our health.
And this invisible fire, it has very real consequences. You feel it. It shows up as persistent fatigue because your energy systems are damaged. It shows up as brain fog, as insulin resistance, which is the hallmark of type 2 diabetes, atherosclerosis, which is the hardening of the arteries, and just that general tissue damage we all associate with aging.
And that's the bottom line. This is the ultimate outcome. This entire cascade, from the electron leakage to the oxidative stress to the chronic inflammation, it fundamentally accelerates the aging process. Our bodies begin to break down so much faster than they really should. But, and this is a big but, here's the good news. This is not a one-way street, not at all. Our mitochondria are incredibly responsive to our lifestyle. We can stop the damage, and we can even help them reboot with a pretty clear rescue plan. Okay, so the rescue plan has 5 key parts. Number 1, exercise. This doesn't just burn fuel, it actually triggers your body to build new, healthy mitochondria. Number 2, time-restricted eating or fasting. This gives your whole system a much-needed break, and it turns on a cleanup process that removes the damaged mitochondria. 3, lower your intake of foods that cause massive glucose spikes. 4, build muscle. Muscle is a huge consumer of glucose, and it acts like a bigger, safer fuel tank for your body. And finally, number 5, make sure you're getting key micronutrients like magnesium and B vitamins, because those are the essential nuts and bolts for the mitochondrial machinery. So, as we wrap this up, I want to leave you with a question to really think about. We've talked about what happens when the system overloads inside the cell, but what about all that excess energy that can't be burned and can't be safely stored anymore? If your mitochondria can't handle it, where does it all go?